Hello, in this lesson, I want you to evaluate functions by using synthetic substitution. I want you to determine whether a binomial is a factor of a polynomial by using synthetic substitution. So when we use long division, and if I divide by a root, I get this remainder. Well, notice if I go back and I check by replacing that number in there, my remainder is my answer when I use synthetic division. So what happens is you can evaluate functions in two different ways. Here's how we usually evaluate a function. I want to find f of 4. So what I'm going to do is I'm going to go 3 times 4 raised to the 4th power. Come on, 4. My 4 won't show up there. There we go. Minus 2 times 4 to the 3rd power. Plus 5 times 4 plus 2. Okay, well 4 to the 4th is 256. So I have 3 times 256 minus 4 cubed, well that's 64. Plus 5 times 4 is 20 plus 2. Well, let's keep on evaluating. So I take 3 times 256. I get 768. Minus 2 times 64 is 128. Plus 20 plus 2. Now, let's just evaluate that. So take 768 minus 128 plus 20 plus 2. That's usually how you see it. That's usually how we do this. Now, let's use synthetic substitution. So what I'm going to do is I'm going to go 4, and then I'm going to have 3x to the 4th, negative 2x cubed, 0x squared, 5x, and 2. Now notice what happens. I bring down my 3. 4 times 3 is 12. I get 10. 10 times 4 is 40. 40 plus 0 is 40. 40 times 6, or sorry, try that again. 40 times 4 is 160. So I get 165. If I take 4 times 165, I get 660. So 662. Notice my remainder is 662 no matter how I do it. And we call this synthetic substitution, which I think is a lot easier than substituting or long division all the time. Although, notice both are the same. But if I ask you to do it by synthetic substitution, I want to see your work for this part. Let's take a look at example 2. It says the number of college students from the United States who study abroad can be modeled by this function. 0.02x to the 4th minus 0.52x cubed plus 4.003x squared plus 0.09x plus 77.54, where x is the number of years since 1993. And S of x is the number of students in thousands. How many U.S. college students were abroad in 2020? Well, first of all, let's figure out what x is. We know from 1993 to 2020, that will be 27 years. So x is 27. So now I'm going to use synthetic substitution. I'm going to go 27. I'm going to go 0.02 x to the 4th, negative 0.52 x cubed, 4.03 x squared, 0.09 x, and 77.54. So bring down the 0.02. So 27 times 0.02 is 5.4. And let's subtract 5.52 from that. We get 4.88. Take that times 27. We get 131.76. We'll add 4.03 onto our answer. We get 135.79. Take that times 27. And we get 3666.33. Well, to that I'll add 0.09. I'll get 366.42. Finally, let's switch pen colors here so we can see the difference. Take that times 27, and I'll get 98,993.34, and we'll add 77.54 onto that. So our remainder would be 99,070.88. And since we're modeling college students, I'm going to round that, and I'm going to say that's about 99,071. And that's how many we would expect in the year 2020 if this model holds correct.